Okay, welcome folks. This lesson is going to be on absolute value functions and their key parts. Just a reminder that an absolute value function is this sort of V-shaped function here. Looks kind of like a quadratic function, except it's a V instead of a U. The parent function is f of x equals the absolute value of x. Remember that this means the absolute value means the distance of a number from 0 on the number line. So if you take the absolute value of -4, that equals +4. And if you take the absolute value of +4, that also equals +4. So you can kind of think of the absolute value as the positive value of a number. Your general equation is f of x equals a times the absolute value of x minus h plus k. Note how similar this looks to the vertex form of a quadratic equation. The parameters of this equation: a is your vertical stretch, h and k are the coordinates of the vertex, and the equation for the axis of symmetry is x equals h, which is the x coordinate of the vertex, and that's just the vertical line that goes up and down through the vertex. If your a value is positive, you're going to have a right side up v. If your a value is negative, you're going to have an upside down v. If a is greater than 1, the graph is going to be tall and skinny, and if a is less than 1, the graph will be short and wide. Your domain is going to go from -infinity to +infinity. So that's been kind of true for all of our functions so far. We haven't really come across any functions where they have a domain restriction. Your range, if a is positive, your range will be from k to infinity. So that's going to be all the values above the vertex, including the vertex. And if a is negative, then your v would be upside down. So that's going to be all the values below the vertex, including the vertex. And remember that k is the y value of the vertex. So when we're talking about range, we're talking about y values. Absolute value functions, intervals of increasing and decreasing. So this should look a lot like the intervals of increasing and decreasing for quadratic functions. If the a value is positive, your v is going to be right side up. And so then what we can see is our function is going to be decreasing, decreasing, and decreasing from -infinity all the way until we hit h. And then at h, it's going to be increasing, increasing, increasing. Excuse me, after h, it's going to be increasing, increasing, increasing. So that your interval of increasing will be from h to infinity. If your a value is negative, then your v is going to be upside down, and so your intervals of increasing and decreasing are just going to be opposite. You'll have an interval of increasing from -infinity all the way until we hit the vertex at h, and then your interval of decreasing will be from h until infinity. Okay, let's go through a couple of examples. I've got 4 in this video. Given the following equation, determine the vertex, intercept, and intercepts of the absolute value function. Create a table and graph of the function. Finally, write the domain, range, and intervals of increasing or decreasing. Excuse me. Okay, so here's my equation. I'm going to start by identifying my vertex. That's going to be at 5, -2. Next, I'm going to do my axis of symmetry. That's going to be at x equals 5. My y-intercept, that's going to happen when I take my function and plug in 0 for x. So I'm going to take my function. I'll put in a 0 wherever I see x. 0 minus 5 is 5, is negative 5. The absolute value of negative 5 is 5. Negative 3 times 5 is negative 15. And negative 15 minus 2 is negative 17. So I'm going to have my y-intercept at 0, negative 17. To get my x-intercepts, I'm going to set my function equal to 0. So here's my equation. I'll set it equal to 0. I'm going to add 2 to both sides. That will give me 2 equals negative 3 times the absolute value of x minus 5. Divide both sides by negative 3. We'll get negative 2/3 equals the absolute value of x minus 5. This has no solution. The absolute value can never equal a negative number. It can only be 0 or a positive number. Okay, so because this equation has no solution, we can say that our graph has no x-intercepts. We'll see why that is when we graph it. Our vertex is at 5, negative 2. Let's figure out another point that this graph goes through. We don't want to use the y-intercept because that's not going to be in our window. Negative 17 is below the window of our graph. So what we're going to do is we're going to take our function, our equation, and we'll plug in 4 for x. So here's my equation. I'm plugging in 4 for x. 4 minus 5 is negative 1. The absolute value of negative 1 is positive 1. Negative 3 times 1 is negative 3. Negative 3 minus 2 is negative 5. So when we plug in 4, we get an output of negative 5. And then what I'm going to do is pick a point that is symmetric about the vertex. So 4 was one x value before the vertex, and so I'm going to pick a point that's one x value after the vertex at 6. And the reason why I'm doing this is because the function is symmetric about the vertex, I know that these two points will have the same y value. And if that's confusing, you can always just plug numbers into the function and get random points. I just wanted to pick points that are symmetrical because it'll make it easy to graph. Okay, so now I'm going to plot my points. I've got 5, negative 2, 4, negative 5, and 6, negative 5. And I will draw the graph through those points. Domain, negative infinity to infinity. That's true for all of these absolute value functions. The range will go from negative infinity to negative 2. Negative 2 is the highest point on our graph. Remember that we need to use the bracket to include negative 2. Interval of increasing, looks like it's increasing from negative infinity all the way to 5. And then it's decreasing from 5 to infinity. Okay, so that's my first example. Take a screenshot of this if you need it. Let's do one more example of graphing a function. Here my equation is 1/5 times the absolute value of x plus 4 minus 3. Let's start by identifying our vertex, which is going to be at negative 4, negative 3. Our axis of symmetry will be x equals negative 4. Let's figure out our y-intercept by taking our equation, and then we'll plug in 0 for x. So I put in 0 for x. 0 plus 4 is 4. The absolute value of 4 is 4. 4 times 1/5 is 4/5, or 0.8. And then if you use your calculator, 4/5 minus 3, or 0.8 minus 3, is negative 2.2. And so we end up with the point 0, negative 2.2 for our y-intercept. And then our x-intercept, we'll get that by taking our equation, and we're going to put in 0 for y this time. And remember that f of x equals y, so I'm putting in 0 for f of x. I'm going to start by adding 3 to both sides. That gets me 3 equals 1/5 times the absolute value of x plus 4. Now I'll multiply both sides by 5. You might think divide by 1/5. That's okay too. Dividing by 1/5 and multiplying by 5 are the same thing. Either way, you'll get 15 equals the absolute value of x plus 4. So now what I'm going to do is split this into two equations. So 15 equals x plus 4 and negative 15 equals x plus 4. You do this whenever you're solving an absolute value equation, and that absolute value equals a positive number. I'll subtract 4 from both sides of the first equation and get 11 equals x. I'll subtract 4 from both sides of the second equation and get negative 19 equals x. This equals sign shouldn't be here. So then my x-intercepts will be at 11, 0 and negative 19, 0. So 11, 0 and negative 19, 0. Let's put some points in the table. I'm going to start with negative 4, negative 3. And then what I want to do is pick points that will give me whole numbers for my x and y values. So I'm actually going to pick 1 just because I know that that's going to work out to be a whole number. I'll show you why in a second here. So if I put in 1, oh, this has a mistake. Shoot, here. Oops, that should say 1. I bet that mistake is the whole way through. 1, 1. Okay, last one. We're putting in 1 for x, not negative 3. I'm not really sure where the negative 3 came from. Maybe we'll see in a second here. Okay, let's go back to here. Okay, I put in 1 for x. So then I get f of 1 equals 1/5 times the absolute value of 5 minus 3. Absolute value of 5 is 5. 1/5 times 5 is 1. 1 minus 3 is negative 2. So my first point is going to be at 1, negative 2. This point was 5 x values in front of negative 4. If I go 5 x values behind negative 4, I'll be at negative 9. And then again, because these points are symmetric, we'll end up with the y values at negative 2. If this is confusing, don't worry about it. You can really pick whatever points you want. I'm just picking points that are whole numbers and symmetric because they'll be easy to plot and because it will show the symmetry and shape of the function. Okay, so I plotted my points. I'm going to include my draw my graph through those points. I get this. Domain, same as it's been, negative infinity to infinity. Range will go from negative 3 to infinity, so we're picking all the values above negative 3, including negative 3. Interval of increasing will go from negative 4 to infinity, so I'm increasing as I go to the right of my vertex. If I look at my points to the left of the vertex, now I'm decreasing. So that'll be negative infinity to negative 4. Go ahead and take a screenshot of this if you need it. This is all the answers to the second example. We've got 2 more examples to go through. With these next 2 examples, I'm going to go from the graph and use that to write an equation. So for my first graph, I'm going to start by just identifying some points that the graph goes through. Okay, and then I'll put those points in the table. One of those points that I identified was the vertex, right, at 3, 0. I can use that to write my axis of symmetry at x equals 3, just the x coordinate of the vertex. And I can also use my vertex to write my equation. So the equation is, the general form is f of x equals a times x minus h plus k. Remember that h and k are the x and y coordinates of the vertex. So this will become f of x equals a times x minus 3 plus 0. But we don't really write the plus 0 part, right? At least that's not how it would show up in a textbook. If you write plus 0, that's fine. I just get rid of it on mine. Okay, now I'm going to take my equation. And then what I'm going to do with my equation is plug in another point that the graph goes through. I have to pick a point besides the vertex, because that won't work because I used the vertex to write the equation. So I'll use 7, negative 3. So I'm going to put in 7 for x and negative 3 for y. Now what I'm going to do is solve for a. 7 minus 3 is 4. The absolute value of 4 is 4. I'll divide both sides of the equation by 4 and get negative 3/4 equals a. So then I'm going to substitute negative 3/4 for a in my equation. Now that I have a completed equation, I'm going to use that to solve for the y-intercept. So I'll take my equation and I'll put in 0 for x. F of 0 equals negative 3/4 times the absolute value of 0 minus 3. 0 minus 3 is negative 3. The absolute value of negative 3 is positive 3. Negative 3/4 times 3 is negative 9/4, or negative 2.25. So I can say that my y-intercept is 0, comma, negative 9/4. Or if you want to write it as a decimal, that's fine too. My x-intercepts, I'm going to take my function. Now I'm going to plug in 0 for y instead of x. I'm going to divide both sides by negative 3/4. This is the same thing as multiplying by negative 4 over 3. Either way, when I do that, I get 0 equals the absolute value of x minus 3, because 0 divided by anything is just 0. Now I'm going to split this into 2 equations. Oh, sorry, excuse me. This is the one time when you don't split an absolute value into 2 equations, is when it equals 0, because you can't do positive and negative 0, right? 0 is neither positive nor negative. So 0 equals x minus 3. Add 3 to both sides, x equals 3. And so we get our x-intercept at 3, 0. Note that this is also the vertex, and I think that's worth pointing out. This is the one time where the vertex and the x-intercept are the same point, when the vertex is on the x-axis. Your domain goes from negative infinity to infinity, right? That's true for all these absolute value functions. The range for this one will go from negative infinity to 0. We're including all the y values below 0. The interval of increasing will go from negative infinity to 3. So increasing, increasing, increasing until we hit the vertex. And then we'll be decreasing, decreasing, decreasing afterwards. Go ahead and take a screenshot of this for example 3. Okay, last example. Given the following graph, determine the vertex and x-intercepts of the absolute value function, write an equation for the function, and finally write the domain range and interval of increasing and decreasing. Okay, so let's start by identifying some points. I'm picking -5, -10, -6, -6, and -4, -6. Put those into the table. -5, -10 is my vertex. So my axis of symmetry is at x equals -5. This is the general form of a absolute value equation. So now I'm going to put in my vertex for h and k. So I'll end up with x plus 5. Sorry, f of x equals a times the absolute value of x plus 5 minus 10. Now I'm going to take my equation and I'll plug in another point that the graph goes through. I'm picking -4, -6. So I'm putting in -4 for x and -6 for y. -4 plus 5 is 1. The absolute value of 1 is just 1, so I'm just getting rid of that. Now I'm going to add 10 to both sides. I'll get 4 equals a. So then I'll substitute that in for a. Now I'm going to take my equation and solve for the y-intercept. The way that I'm going to do that is I'll take my equation and I'll put in 0 for x. 0 plus 5 is 5. Absolute value of 5 is 5. 5 times 4 is 20. And 20 minus 10 is 10. So my y-intercept is at 0, 10. You can also see this up at the top of the graph if you wanted to eyeball it. For my x-intercepts, I'm also going to take my equation, but now I'm going to plug in 0 for f of x. I'll add 10 to both sides. 10 equals 4 times x plus 5. Divide both sides by 4. 2.5 equals the absolute value of x plus 5. Now I'm going to split this up into two problems. I'm going to say 2.5 equals x plus 5 and -2.5 equals x plus 5. Subtract 5 from both sides. We'll get -2.5 equals x. Subtract 5 from both sides. We'll get -7.5 equals x. So my x-intercepts will be at -2.5 and -7.5. And we can kind of eyeball that on the graph. That looks about right. That's about -2.5. That's about -7.5. Okay, domain will go from -infinity to infinity. Range is going to be all the values above my vertex. So all the values above right here. My vertex, the y value is -10. So this will go from -10 to infinity for my range. Interval of increasing. That's going to be everything after the vertex. So from -5 to infinity, my graph is increasing. From -infinity until we hit the vertex at -5, the graph is decreasing. So here's my last example. Go ahead and take a screenshot of it if you need it, and let me know if you have any questions. Thanks for watching.